Hello everyone and welcome back to our channel. So for today the question is, a developer is maintaining a fleet of 50 Amazon EC2 Linux servers. The servers are part of an Amazon EC2 auto scaling group and also use elastic load balancing for load balancing. Occasionally some application servers are being terminated after failing ELB HTTP health checks. The developer would like to perform a root cause analysis on the issue, but before being able to access application logs, the server is terminated. So the question is, how can log collection be automated? Options are: use auto-scaling lifecycle hooks to put instances in a pending wait state, create an Amazon CloudWatch alarm for EC2 instance terminate successful, and trigger an AWS Lambda function that invokes an SSM run compound script to to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. Option B. Use autoscaling lifecycle hooks to put instances in a terminating wait state. Create an AWS config rule for EC2 instance terminate lifecycle action and trigger a step function that invokes a script to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. Option C. Use auto-scaling lifecycle hooks to put instances in a terminating wait state. Create an Amazon CloudWatch subscription. Filter for EC2 instance terminates successful and trigger a CloudWatch agent that invokes a script to collect logs. Push them to Amazon S3 and complete the lifecycle action once logs are collected. Option D. Use auto-scaling lifecycle hooks to put instances in a terminating wait state. Create an Amazon event bridge rule for EC2 instance terminate lifecycle action and trigger an AWS Lambda function that invokes an SSM run command script to collect logs, push them to Amazon S3, and complete the lifecycle action once logs are collected. So the answer is option D. Next question is, a company has an organization in AWS organizations. The organization includes workload accounts that contain enterprise applications. The company centrally manages users from an operations account. No users can be created in the workload accounts. The company recently added an operations team and must provide the operations team members with administrator access to each workload account. So the question is, which combination of actions will provide this access? Option A. Create a sysadmin role in the operations account. Attach the administrator access policy to the role. Modify the trust relationship to allow the STS assume role action from the workload accounts. Option B. Create a sysadmin role in each workload account. Attach the administrator access policy to the role. Modify the trust relationship to allow the STS assume role action for the operations account. Option C. Create an Amazon Cognito identity pool in the operations account. Attach the sysadmin role as an authenticated role. Option D. In the operations account, create an IAM user for each operations team member. Option E. In the operations account, create an IAM user group that is named sysadmins. Add an IAM policy that allows the STS assume role action for the sysadmin role in each workload account. Add all operations team members to the group. Option F. Create an Amazon Cognito user pool in the operations account. Create an Amazon Cognito user for each operations team member. So the correct answer is option A, B, and E. Next question is, a company has multiple accounts in an organization in AWS organizations. The company's SecOps team needs to receive an Amazon Simple Notification Service notification if any account in the organization turns off the block public access feature on an Amazon S3 bucket. A DevOps engineer must implement this change without affecting the operation of any AWS accounts. The implementation must ensure that individual member accounts in the organization cannot turn off the notification. So the question is, which solution will meet these requirements? Options are: A. Designate an account with a delegated Amazon Guard Duty Administrator account. Turn on Guard Duty for all accounts across the organization. In the Guard Duty Administrator account, create a SNS topic. Subscribe the SecOps team's email address to the SNS topic. In the same account, create an Amazon Event Bridge rule that uses an event pattern for guard duty findings and a target of the SNS topic. Option B. Create an AWS CloudFormation template that creates an SNS topic and subscribes the SecOps team's email address to the SNS topic. In the template, include an Amazon Event Bridge rule that uses an event pattern of CloudTrail activity for S3, put bucket public access block, and a target of the SNS topic. Deploy the stack to every account in the organization by using CloudFormation stack sets. Option C. Turn on AWS config across the organization. In the delegated administrator account, create an SNS topic. Subscribe the SecOps team's email address to the SNS topic. Deploy a conformance pack that uses the S3 bucket level public access prohibited AWS config managed rule in each account and uses an AWS systems manager document to publish each account and uses an AWS Systems Manager document to publish an event to the SNS topic to notify the SecOps team. Option D. Turn on Amazon Inspector across the organization. In the Amazon Inspector delegated administrator account, create an SNS topic. Subscribe the SecOps team's email address to the SNS topic. In the same account, create an Amazon Event Bridge rule that uses an event pattern for public network exposure of the S3 bucket and publishes an event to the SNS topic to notify the SecOps team. So the correct answer is option C. Next question is, a company has migrated its container-based applications to Amazon EKS and want to establish automated email notifications. The notifications sent to each email address are for specific activities related to EKS components. The solution will include Amazon SNS topics and an AWS Lambda function to evaluate incoming log events and publish messages to the correct NSS topic. So the question is, which logging solution will support these requirements? Options are A. Enable Amazon CloudWatch logs to log the EKS components. Create a CloudWatch subscription filter for each component with Lambda as the subscription feed destination. Option B. Enable Amazon CloudWatch logs to log the EKS components. Create CloudWatch logs insights queries linked to Amazon Event Bridge events that invoke Lambda. Option C. Enable Amazon S3 logging for the EKS components. Configure an Amazon CloudWatch subscription filter for each component with Lambda as a subscription feed destination. Option D. Enable Amazon S3 logging for the EKS components. Configure S3 put object event or notification with AWS Lambda as the destination. So the correct answer is option A.